Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. Back again for a, well, 3-week break, I guess. 3 weeks since the last time we did one of these. This is bug squashing part 11. Ugh. We're still working on this graphics corruption bug. I think last time I got mednafen building right at the end. Be continuing on there to try and instrument that and print some stuff just to see if we can find any sort of obvious differences. Once we do, and I'm sure we will, then we'll have to start digging into why. But we're still just gathering information. And I hope this will go fairly well. But we'll see. By the way, hey to guys in the chat. Rep Nop, Daru2, Daniel Collin, Giant Jelly Matt, and Phil Daddy 69. It's a fun name to say. Enjoy your meeting, by the way, Daru2. Hey, Mad Moose. I assume that DK at the end of your name is Denmark and not Duck. Hey, Love Like Semtex. So, yeah. So, it's been a few weeks, so a little bit of context has escaped my mind, admittedly, but fairly certain we've still isolated this memory location here. These are the values that are being written to it. And particularly, we're looking at this 08-bit, which determines whether or not there's sound playing in the interrupt handler. Hey, Dark Second. Hey, Zeg Jeff. So yeah, I wanted to also instrument this kind of printing in mednafen and get that working there. I actually forgot to plug in my controller, which I'm going to need when I get mednafen running. 1 second here. Things are a bit of a mess here, as I've been getting new old hardware in the mail. And I've been setting a bunch of stuff up. I'm actually in the middle of resurrecting a 586 to hopefully turn it into sort of a disk station that I can talk to over network to write some floppies out. I think I'm close to getting that working. Giant Jelly Matt, glad to hear you like the makeshift breakdown. I actually found a mistake in there, by the way. I'll talk about it for a second here. It's actually a mistake in the note. I don't think I made this mistake in the stream. But the... I think I mentioned when I was reverse engineering the plasma effects in Edge of Disgrace that I said that they use a hardware trick that repeats the 7th line of every character for their whole screen. And that's actually not true. They actually end up using the same hardware trick that I end up using, which actually repeats every character line. Has an added benefit that the timing is a little less critical, and you don't have to wait for the first 7 lines to scan out before you start repeating the 7th. Or the first 7 lines, because the 7th is 0 and next is actually the 8th line. That makes sense. So that was a small mistake I made, but in the intro, the code is correct. Like Jeff 586, yeah, it's a Pentium. The reason I need that is because I'll actually show you. Getting sidetracked already. This is why I love this stream. Let's see. This bad boy came in the mail recently. This is in HB-F1XD. The MSX machine I've been talking about. So sexy. It appears to work just fine, except that I have no way of getting disks written for it. I tried with a USB floppy adapter, and that worked like ass. So I ended up bugging some people at work, and one of them came through for me with a Pentium, and it's a just big old hunk of metal. It's just a terrible machine. 75 megahertz, 32 megs of RAM. That'll be enough to run some really lightweight Linux distribution and hopefully a Rust program that'll write out the disks. And I bought a bunch of adapters and stuff. Got a hard drive for that. It's actually SATA. So I got a SATA to IDE adapter that I hope will allow me to populate the disk from my main PC and then put that into the old PC. That's what I'll be doing after the stream. And I'll probably do some videos on it once I actually finish the setup, because I think it'll be kind of cool when it all works, but yeah. That's rad. But yeah, I was calling it a 586 rather than a Pentium, because I've been thinking about the build setup that I'm gonna have for that, getting the right kind of version of the operating system and all that stuff. And so the number 586 has been stuck in my head for a little bit, rather than Pentium, because you usually don't write Pentium in a version string, but you'll write 586. Not yay, more stuff. More new old stuff. It's good stuff. So yeah, probably better to call that a Pentium, but that's at least why I said 586, I think. Anyway. Time to dig in. So right at the end of last episode, we got that mednafen project running. But I couldn't get it to rebuild. Some of the comments on YouTube, I think, were pretty helpful in that I should have done also make install. I actually want to dig through that make file a bit and see, and the instructions that came with it. See a little bit about that. Even though reading's for nerds. Yeah. Shut this down. So I gotta pull this stuff up again. By the way, I don't know if you guys can tell. I have a different keyboard this time. And I'm not quite used to it yet, but it's nice. They are cherry reds. This is a Corsair K75, I think. K70 RGB. I bought it because I loved my K95 that I had in the US. I'll still need to get that back at some point, but I had to buy a new keyboard because I'm repurposing my old one because it has PS2, so that's going to be for the 586. The Pentium, there, that one. That thing doesn't have USB or anything. Hey, Chica Mishka, it's been a while. Slater Repnop. Yeah. Hey, TJ. So let's just do make here. I don't think make install did anything particularly useful, but it may have. That's not mednafen. Where did this build to? I don't remember. Thanks, Love Like Semtex. Yeah, that one was really fun to do. The whole demo was just crazy. It's just really fun. Wasn't source, was it? Of course it was. That's acting a bit strange. I probably should have just watched the end of last video before I dug into this, but what happened here? Should, by the way, be running this in a different terminal. Hey, Zamak. Oh, this keyboard's so bouncy. Just because I want to see where this is going to go. Just going to do... Whoops. Did not mean to hit the close thing there. Generally, Matt, haven't done any old school assembler programming before. Is C64 a good thing to start with? I actually think it totally is. Although, only if you can find a good monitor and start working in there. That's actually how I started with that. Or initially, I actually looked into Super Nintendo because that's what I grew up with. Ended up picking up C64 because of the demo scene, and it was a little bit easier to get started than Super Nintendo. At least for me, to understand some of that stuff. The 65C816 is not a fun CPU to work with, but 6502 is quite alright. Except it doesn't have very many registers, but... another thing, something Z80 based might be nice. Oh yeah, PMR source. Good call. Yeah, that would make sense. Is there a make uninstall? Probably not. Whoops. We're also in the wrong directory. But yeah, I think PMR source. I think you're absolutely right. I think that was the mistake I made last time. And there's a make uninstall. Nice. Ferris makes emulators, exactly. Nice. Yeah, generally, if you look up like demo coding on there or something, I think you'll find some. I can't remember because I remember reading some tutorial, and this was around like 2009. I can't remember whose it was, but it was some demo coding tutorial. And they start with like raster bars and some crap like that, and it was really fun. So I absolutely enjoyed that. When I say crap like that, I don't mean to belittle it. It was just nice. I think I did this in 32-bit last time. Let's see. Actually, just in case, because I did a make with the 64-bit stuff, I should restart this. And I definitely remember doing it out of one of these terminals here because of the MSys setup, which normally makes it a bit simpler than just straight min-GW. Ah, yeah. SJ, let's do 6 jobs. Might restart some of that work, but I think it'll be faster. Yeah, lately I've actually been trying to take it easy. But when I'm unable to do that, I've been actually doing some timing tests for C64 stuff. Found that LFT did a really good timing chart of the different events that happen as the display is processed. And I've been sort of cross-referencing that with a document that describes some of the internal registers inside the VIC chip in the C64 that were discovered through some reverse engineering efforts in the 90s. And some really interesting stuff, and just kind of trying to match up, like, there's these 5 rules that describe these internal registers, kind of understanding those and then using those to predict, oh, so when I'm using this hardware trick, that's because this register is being manipulated this way because of the scroll value, and so on, and just trying to match the different hardware tricks with that understanding. Kind of a lot to dig through, but it's really fun. Just speaking of old school assembler programming. Also, the nice thing about doing that old school assembly stuff is it's just you and the machine. So like it's a pretty isolated environment, I think. So like I learned a lot about computer architecture that way. And it's also kind of one of the reasons why I really like making emulators and working on this kind of stuff, is because I like to learn how this kind of hardware works. Mad Moose, don't start on a C64 emulator before you finish this one. I totally won't. I won't do a C64 emulator. Like, Vice is just too good. It's kind of, I feel kind of the same way with BeastNet, now called Higan. But, like, I don't really want to do a Super Nintendo emulator either. It's just too good. Now, after this one, I'll go back to the N64 for sure. Yeah, exactly, Zagjev. That'll definitely be my next emulation project. Unless I find out the MSX emulators are really bad. I'm just kidding. I'll do the N64 one next for sure. In fact, this emulator was not meant to be this much of a distraction, but it's just been going so well, so it's been fun. It already is emulatorception. Actually, speaking of which, I'm pretty sure there's a Game Boy emulator for Virtual Boy, which is just awesome. Don't remember who's doing that. All right, so that worked, I believe. And just running that seemed to work, which is really nice. Port Virtual Boy emulator N64, emulate N64. Yeah, that's definitely what I need to do. If I had VR hardware, I would totally add VR support to something like that. But my policy is basically this. If anyone else wants to do that, I will totally help. So we got mednafen here, and I think I just need to specify the stuff. Actually, it's going to be here. And we're booted. Let's see if it remembered my key mappings. Looks like it did, which is really good. And we are getting some audio, which is also good. The Sweet says an AVR microcontroller assembler is also a good start. That's a good point, actually. I think it's a similar environment. In fact, it's even more minimal. I remember doing some embedded C back in the day. I don't think I ever did assembler for that, but yeah, also some nice stuff. Okay, so this is running. So let's see. Let's dig into the prints that we did before. I think just got to pull up the source here. And I don't exactly remember where this was, but I'm guessing VB is a good place to look. In fact, a git diff should tell me what this is. Oh yeah, but I don't have this in a git repo. What I actually kind of wish I had done is even just made a git repo here and just made an initial commit, which at least would have been nice because I could have seen the diffs here. But I guess I could have also just copied the directory and done diffs that way. Anyway. Here's one. Yeah, okay, so this is definitely what we did. We did this mednafen printf thing. And not sure if that's going to go where we want it to go, and that's kind of where we were a little bit stuck there. Because here we should have definitely seen output from that. In fact, especially because of this one here, which is all these mem rights. I think there was a, like, I don't want to do a git in it now because we have a bunch of build files here, and then they're not going to be ignored. So I'm not sure I want to do that right now, but I think, where was the help for this? Can't remember how I found this even. Guys, don't make your CLI this shitty, by the way. Dig into the docs. Just gonna scan all this because I tend to skip over things. Well, was that the whole usage thing, or was that another section of that? Yeah, I actually ended up reading through this, which is a bit annoying. One second here. I believe there was an environment variable to route this. we had last time. And I do not remember what it was. Yeah, I don't remember if it worked either, but I want to try it. No STDIO redirect. SDO 1.2, sorry, which is what we're working with as far as I remember. I can't remember how we used it either. Because I don't think we just say this. Although, now that we know we should be executing the right mednafen at least, we might actually be getting those output files. It should save those. For example, and I guess that's where all the CLI shit went. So let's run this here. Or actually, we'll run this with the Mario game. And then we'll do this to see what it gave us. All right, so we actually are getting these prints, which is awesome. Nice. So now I want to redirect STD out so we can actually read it in real time. Yeah, so that was definitely, I think, the issue at the end of the last episode was that I was running the installed one because I ended up doing make install, which was a mistake in hindsight. So I know there was an environment variable to do this. I don't think printf will work. Well, actually, if I specifically print to STD out. Well, no, because if that's redirected. Doesn't that redirect happen at a lower level than that? I think. I mean, now that this actually. Oops. Now that we can do all this, it's actually probably worth trying. but I'm pretty sure that'll redirect as well. Oh, it bugs me though because I know that there was a environment variable used for this. I'm actually literally going to pull up the video from last week. Or last time, I should say, because it wasn't last week. Because I'm fairly certain we got output there, but then I was running the wrong mednafen so that we didn't see the stuff that we added. But now we've solved that problem. So if we can solve the other problem, then we're definitely in business. This is what I see when I watch me.
Hey guys, how's it going?
Whoa.
How's it?
All right, mute that. This asshole. So at some point we got some output. Where was it? It's towards the end for sure. This is pretty meta right now. I should like try to do what he's doing. How to match his face. At least where he's looking. It's hard with the tilt. Ugh. It's doing that MSys cutting off the text thing, so I actually can't see what he is in me wrote. Damn you past me! See if any of the comments had this. New double density floppies. Hell yeah. Still got them. Although a couple of them are formatted now. See this thing that MSys does. Hate that. I can multitask a little here. I just miss it, did I? I don't think so. Ugh. I totally don't remember this. So I'm trying SDL SCDI redirect. I think though. Let's try this. Does it work if I do it here? Let's just try that. Bam! Okay, so it needs to be set to no. All right, I can shut down this douchebag. Cool. All right, so now we actually have printing here, which is fabulous because now we can actually start isolating things here. So this should give us what we want. Yeah, the compressor. I really don't think we'll like this very much. But it should be fine. All right, so now let's just observe a bit. Boy, does that look familiar. Look at those values almost being the same. Do I have different font sizes here? That'd be crap. I'm gonna actually fix that so we can compare this easier. What? Oh yeah, it's because they actually have different text. Hey, Zafira. Interesting. It just had a couple different values in here. Right here. When it switched screens. Just want to see if ours does the same thing here. Oh yeah, the controller doesn't work on mine. Doesn't work on the floor either. Okay. So here's actually something pretty interesting. Oh no, here it is. Here it writes 2. See that? Oh, check this out. This is actually really cool. 100, 102, 2. C0A, C0A, C02. Guys, look how in step this is. I did not expect this. Eventually goes 1199 199. Wow. I did not expect these to agree this much. I am shocked, actually. I really did not expect this. Just scrolling bit by bit. 1, 2, 1, 2. Okay, that's as far as I go on each of these. These are identical. I'm going to say that right now. Like this one stands out because the length is different. And here the length isn't, it's all normalized. But you can see, like if we start here at this 02, which is just some kind of anchor, these are exactly the same. And I'm not happy about that. Because I was really hoping these would be different. As I don't really have a lot of other leads at the moment. I just put these like exactly side by side here. That's crazy though. I cannot express how little I expected that. Well, yeah, it might be worth doing a proper diff. Need to adjust the output a bit to actually make it match, but yeah. Because there's some offsets here and stuff. But I'm reading through this and I'm seeing the same numbers, which is really disturbing. Because this is really my main lead here. Even for a while, it looks pretty similar. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Wow, these are a lot alike. Small difference somewhere here. Wow. Yeah, some of them should still be different. Remember, we're not logging all writes here right now either. This is just that one address that we kind of isolated. Very interesting though. I really was hoping this would be at least more obviously different. But let's do this. Is there a mem write 16? I don't think mednafen has a debugger like we do. It might, but there's also the thing of, do I want to sit here learning that, or do I want to just keep digging in the code? Hey, Ripnop. We got output from mednafen, and it looks way too similar to ours. Like, concerningly similar. I actually want to see, though, because we're only instrumenting memwrite 8 here. Oh, no, we are actually doing 16. Hold up here, then. Just to make sure this is actually outputting the right stuff. Hey, Duro 2. And now this output should be like exactly the same. Same format and everything. So now again, if I isolate where this O2 is, just because that was some kind of anchor. In fact, we can even do it this way. Or we're a little bit off here. This is a poor man's diff, and the reason why I'm doing it shitty like this, by the way, is because I would need to anchor this in the text anyway. And I just want to eyeball this first. Oh, this is so disturbing though. I'm gonna remove these output things from ours. I actually really, the other thing about the diff, again, guys, is, the other thing about the diff is that I don't know how much of our hardware is going to be in sync. And so I honestly expect doing a diff that we would find pages and pages of stuff that's just like subtly different, and then it's going to be way beyond like we're gonna get a lot of crap in the diffs. Is what I would expect. Although might be worth a shot anyway. Cuz just seeing how much these actually do match. Hey Zero Repent, yeah, that's what we're still working on. I'm actually going to do it. I'm going to do a diff of this. How do I do that redirect here? It's just a pipe, isn't it? Okay. The other thing is, like, when I hit these keys, that's going to have different timing. All that stuff. No, don't worry about it, Sophia. No need to apologize. I'm just explaining those concerns. But let's just do this. That's the quickest solution to begin with. Even though I expect this to be crap. Hey, look, Jose. Yeah, here's the other thing. We get a bunch of this crap. Like the startup stuff. But we should actually be able to here get rid of all that stuff before that. Yeah, so already, like, we already see diffs here. And the new lines are different. Yay. Of course they are. And we get spaces in front of all these ones. Not really sure why that is. On the other hand, let's do this actually. I'll take the mednafen one. Or I actually need to do a byte replacement here. Ha! There. Now they're looking a lot more similar. Cool. Just to see. And there we just have a difference that I'm not sure is going to be significant, for example. I do need to find some proper diffing tools, though, if this is the route I'm going to take. But just wanted to see if this helped at all. At least it normalized the files a bit, but we'll see. It's kind of demotivating to have to learn a big diff tool to do this stuff. Let's check out this beyond compare thing. It looks pretty good. Yeah, enjoy localhoster. Let's get a trial of this going. Last I checked, I can read English and not these other languages. And I mean, if this diff tool ends up being good enough and I end up being competent with it enough to do this properly, and this doesn't end up yielding, like this data we're looking at now, that's probably worth looking at some other things. Like printing some additional data and just seeing what ends up mattering, what doesn't. Not do that. Oh, hi. Hi, big window. All right, let's do this. Let's see if I can just drag these in here. Bam. And bam. This is a proper diff here. Especially that it matches up after a while, which is really nice. See some basic differences. Now remember, these actually played different sounds at the beginning and stuff. So I would totally expect some differences here. And all this stuff seems to be pretty minor, which is what we expect. Something here. Define that. Yeah, this was that area we were looking at, which is basically when that screen transition happens, or at least when one of them happens. Okay, there's actually a few of these. That's it? Oh no, this is actually the one we were looking at. This one here. We're down here. This is where that screen transition happened. And man, these sure do match. And that's disturbing to me. Because I know that this 02 here that we were looking at, this is definitely when that screen transitions because I watched it happen in real time. The fact that this is so similar before and after, that shows me that we might have been barking up the wrong tree here. Which is fine, but very annoying. But I think a couple things. First of all, this tool looks to be useful. Because even without knowing how to use this, we already could see some. It's already diffing properly, and I'm very happy about that. So that's good. So if we want to go further with this route, I think that this is viable. Second, we got printing in both emulators, which is nice. So I actually wonder... Hey, look, hoster. We're still working on diffs of the that one bit of that one memory location that I've been looking at for a while. What happened here? What is this? The hell? What is this doing? What the hell is up with Sublime? Okay, whatever that was. Gone now. I'm thinking we just need more info here now. Also, I do actually want to see if we just do this again from mednafen, if it handles that space at the beginning of the line as well. Hopefully it does. Just so we don't have to like post-process that all the time. I'm hoping didn't seem to handle it quite as gracefully. But might still be good enough. Yeah, ignore white space would be quite nice. Let's just search for this. What's this thing called again? Beyond compare. There's a session settings. That makes sense. Can do importance. Hold up. Minor button? What is that? Oh, it's up here. Oh, nice. Ha! Great. Yeah, that's helpful. That's helpful. Yeah, here it's still kind of messed up, and I think that was just due to my timing being so different between these two runs. But this is nice. This means we can work with this, and we've got a workflow here. That's nice. Now I'm concerned with like printing everything, but I wonder if I can at least print some of this stuff. Decompression start, decompression end, and the start of the interrupt in the middle of that. What is this? What is going on here? Okay, I don't know what that's doing, but... Oh, of course. It's all this output for the warnings. Yeah, screw that. Doesn't matter. Yeah, so now we got a bunch of these here. Decompression stuff here. Now let's see if we can detect the same stuff in mednafen. It's going to be probably not quite as straightforward. At least not for me, because I don't know that code at all. But we'll just see. In fact, actually, we can just start with decompression start, decompression end. Let's do that. Let's do this piecewise. That'll be a little easier, I think. So this was step, and we need some state to detect this. Although we only need the state to detect the other stuff. So first of all, we can just start with these checks here. Now, again, I'm really not sure how this is running. But we just gotta start reading some code. I've been doing almost nothing but reading code for several days now. Both at work and at home. But I like code. So this is just in the vb.cpp file, which is probably a decent place to look at least. Read header, test magic, load. Power init. Close game, exit loop. Emulate. Cool, Drew2. Thanks for the tips. I must admit, a couple of those are going to be hard for me to retain at the moment, but they're much appreciated. The emulate, exactly. This is the whole emulate right here. Actually, though, I see start frame and end frame. And V810 run. So that right there is probably actually where it's doing it. V810 run. VB V810 is probably an instance of the V810 object, which I believe is in hardware CPU in here. I have looked at this code a bit, but not much. I'm gonna search for run. Here's run. And it dispatches to these different ones depending on the mode. V810 uploop.inc. Here we go. This code is not pretty. Sorry to whoever wrote this, but that's what I'm thinking. I think see an RB get PC. While running, we do old PC is get PC. Might be enough to just start sticking stuff in here, actually. Think don't know about this, but this should give us the PC at least. So let's just try this here while running. Looks like a decent place to put something. And we had let's try this. Actually, we'll call this some like temp PC. Jake. Let's do Ferris. Just to make sure this doesn't clobber with anything, because you never know. If temp PC Ferris is also that auto thing may not work if we're not using C++ 11 at least, but we'll see. Then what was our print function here? I did it in the right order, so I could type ASDF and find this. Awesome. See if that builds. All right. Let's see what we get. Do it. We didn't get any of these. Why? Those will help. Oh yeah, we are using C++11 there. I saw the standard library specifier. Okay. So now we know what our PC was. Or at least sort of the range that it was in, basically the entire time. Which looks like ROM, so that's good. FFF8-135C. That's disturbing. That it didn't seem to get there? What the hell? Which matches our output, to be fair. Oh, whoops. Okay, so escape closes that diff program. Good. I actually get really annoyed when GUI programs do that. I just keep forgetting what this thing's called. Beyond Compare. Which is a cute name. Oh, good. Saved our session. Thank you, Beyond Compare. Other than the fact that it quit on escape. I like this program. You know what I'm going to do? Oh, hey, wait a minute. This is not printing everything that it should. Straight up. Because I'm fairly certain. There's going to be a couple instructions here. So I wonder if there's like a different loop for this. Which, ugh. You know what we can do, though? Let's do this. So we had it while running. I'm going to actually do that. Good. Much better. Thanks. Here's the thing. If this isn't catching it, something else must be modifying this. Or like there may be another loop when it's actually executing, which, ugh, but could be the case. I'm actually going to print this out in our emulator. Because I want to see. Where did that K come from? This won't be fast. Yeah, this is not fast. What I'm thinking... Actually, with how slow that was, I'm totally thinking... First, I'm going to recap this. I'm totally thinking we're not catching all the opcodes there at all. Hey, looks online. Yeah, I've stopped getting my hopes up, to be honest. Exactly what Durutu says. Takes as long as it takes. Yeah, it's doing some bitstring stuff here. Yeah, we gotta do this in a couple places. Here, there's a loop while the timestamp is just the next event. Actually, RB CPU hook. This is interesting, actually. In fact, I'd argue that's probably where we need to be doing this. Wherever we see that. Let's just try this here. Did I totally get rid of that? Okay, that's fine. There may be set PC, but set PC may happen multiple times per opcode depending on the implementation. Ugh. Uint32. I don't think so. No, that one's not mine. But it is useful. That's actually a good catch. I didn't see that. Here we go. Oh, that's nice to see. Wow, these are really in sync. I'm still just so surprised at this. Really surprised at how in sync these are. Okay, here's something real interesting. Check this out, guys. This never writes to this address while this decompression is happening. Look at that. Is that always the case? Very interesting, actually. That's a good clue. So whatever's writing to this, that never happens when the decompression is happening over here. So I wonder what the deal is there. And in fact, I'd be willing to bet if we looked at all the values here before the decompression started, that 08 bit would never be set, which would also satisfy our interrupt stuff. I want to do this as well to detect when the interrupts happen, particularly when the interrupts happen while the decompression is happening. Just to see again if those are related. And I'm going to be so pissed if no interrupts fire for them while this routine is happening. That would make me so angry. But this is definitely progress. I'm very happy about that. I think I'll do that. I think I'll do that, and I'm feeling pretty tired. So I think we'll do this. We'll get a little bit farther with the printing here and see if we can get it to... Actually, you know what I might do is just print every time there's an interrupt when it starts and ends, just to see if that gives us any more clues rather than only when the decompression is happening. Because that should give us basically the same information given this diff tool is halfway decent. It appears to be. So I think we'll start with that. And then that way I don't have to store the state of whether or not it's in that stuff. I just have to like do more of these. And then we'll see what happens. Here I have them marked the start of the interrupt and the end of the interrupt. Yeah, I think that's just actually the error, the warning highlighting. And Rust enhances being a bit pedantic. I need to tweak that. The little inline errors are actually quite disturbing. I miss the mini buffer in Emacs sometimes. Because that was a great place for errors and warnings and stuff. Give me a little indication that there's something on the side of the line. And expand it at the bottom. Hey, Ratchet. It might be going pretty good. Okay. Damn it. Oh no, wait. No, we're still in line. We're still in line because this is still not when the decompression is going on. Okay, we're still good. We're still good. And we're still, again, surprisingly in sync, which is really nice. Still surprising to me, but generally really nice. And here we go. So actually, here's something awesome, by the way, and I'm actually really happy to see this. The interrupts are still firing when the decompression fires. And you know what that says to me? That says to me that that initial change we made that made Space Squash boot, and the reason this whole thing is called bug squashing, that was a correct change. And the previous fix that I had done for this game is wrong. And right here, this proves it, that the interrupt starts and ends, and this is fine, yet this isn't. So herein lies the difference, and that's actually pretty good. So we know that during decompression, interrupts definitely happen. We also know that the same value is in this one variable here. When the decompression starts and ends. And that's awesome. And man, I'm still impressed at how much these lined up. I really expected that to not be like this. I expect this to be all over the place. So I'm impressed by that, or at least surprised. Here we got another interrupt here. One more than this one had, but we still had the same amount of like decompression starts and ends. And that makes me feel okay about that. Especially considering this, that whatever's making these writes is going to take a little bit more time than not doing them. And so we might have had enough time that another frame would have happened and we would have gotten another interrupt. That's probably what that is. Probably why we got another one there. But yeah. Okay. This is actually really good info. That we know that interrupts are firing during decompression. And we're actually seeing some kind of difference between the two things here. Drew2, I don't actually have any debuggers that allow me to do that when debugging Rust, except I think Visual Studio can do it. Probably many other tools. But in terms of actually debugging the emulator, I totally have those features in my debugger. Mednafen probably doesn't. Or at least I wouldn't know where to look for those yet. But here's what I think. I think this was really good progress because we actually finally saw some difference here. We got a diff tool that's going to help us find differences here in the future. So thanks to you guys for recommending that and all the tips to use that. We have mednafen building and running with output. And so we're able to actually get the information that we're going to diff. We're able to instrument the code in both cases and actually see that they're pretty similar. And we're able to see a definite difference that aligns with our graphics clobbering, that also aligns with what we expected to kind of see here, which I'm very, very happy with. So with this, we have a way forward, which is to figure out what is doing these writes, what code is going through. So in fact, I might even add some kind of state whenever the interrupt starts, the interrupt ends, and I might log all the program counters and just see where they differ, because in that case, the code should be at least similar paths, I think. Yeah, exactly, Mad Moose. That's where we do the PC, and particularly during the interrupts, I think that's all we need to do here. And as soon as we see them differ, then we start looking at the registers and we start digging into there. So I think that's going to be next week, which I'm really happy about. So now we have a definite path forward and a definite difference. So I'm actually quite satisfied with today. So thanks guys for hanging out. We will hit this next week and hopefully find something very interesting. So yeah, thanks again guys for hanging out, and I will see you next time.